Okay, this is a slightly harder version of like a follow-on question. We've we've got the same expression here, x squared minus 2x minus 3, and we want to know where does this equal x minus 2. Okay, now one option is like, okay, standard kind of like quadratic equations, you make them equal to 0. So you'd kind of like have this, and you would subtract an x from both sides, so you get x squared minus 3x, and then you'd add a 2, so you'd get minus 1, and then you'd solve that. Okay, and you might use like, you might kind of factorize it into double brackets if you can, or you might use the quadratic formula, minus b, that big version. But the thing is though, this question doesn't want you to do that. It wants you to solve that equation, okay, or find an estimate to the answer using the graph that we already drew. So we drew the graph of y equals x squared minus 2x minus 3, and we want to find an estimate to this equation using that graph that we've already drawn. And it's dead simple, because what we've done is we've drawn the graph of the left hand side. All we need to do is draw the graph of the right hand side. So we just need to plot on top of this one that we've already drawn the graph of y equals x minus 2, the right hand side. Okay, and that is a really simple equation to draw. It's a straight line. It's y equals mx plus c, and okay, first of all, the intercept is minus 2 and the gradient is 1. So we just need to plot a graph that has a gradient of 1 and it goes through minus 2. Okay, so in order to do that, really, I mean, I would be careful about kind of thinking about what the gradient is on this, because the scale for the x-axis and the y-axis is very different. So what I'm going to do is I'm just going to sub in a number. I'm going to sub in the number x equals 2. Okay, you can sub in any number, but I'm going to just put 2 in and see what that gives us. So y would equal 2 take away 2, which is 0. Okay, so it goes through 0 here. Now, we need to actually draw the line now. So it's a straight line. So let me kind of draw that. Okay, so can I do it like this, or do I need to use, yeah. Okay, so I'm going to have to use this to draw a line, diagonal line. It's not going to be perfect though. Okay, right, so I'll probably need a few more coordinates really, because this isn't going to be really awkward, but I think it goes through something like that. Okay, so here's the kind of line that I've drawn. Obviously, if you do it on graph paper, you get a more accurate version. Right, so we want to solve this equation, or at least we want to find an estimate for this equation. So we drew the graph of that side already, okay, and we've just drawn the graph of this side here. And in order to find out where they equal each other, we just need to look at where they intersect. Okay, so they intersect here. Okay, let me do it in red. Okay, so here's one intersection point, and all we need to do is find the x value that corresponds to that. So one answer is x equals, roughly, what's that? It's probably 3.25. And actually no, it's probably 3.3, isn't it, by the looks of it? Okay, so let's keep it to 1 dp, so 3.3. The other one is roughly here. So what's that going to be? That's probably going to be, so comma minus 0.3. Okay, so there is your kind of estimate for the solution to this equation without having to do any rearranging or anything like that. And let's just see how close it is. So what I'll do is I'm going to put 3.3 into both sides of the equation and see if we give me roughly the same number. Okay, so I'm going to do 3.3 squared take away 2 times 3.3 minus 3, and then I'm going to do 3.3 take away 2, which is the other side of the equation, and I'm going to see if they roughly give me the same number. They should do. Okay, so on the calculator, this gives you 1.29 and this one gives you 1.3. So they're very close. So this is kind of like a rough estimate as to what the answer is. If you want an exact answer, you would have to use the quadratic formula, but this is just kind of like one thing you can do. Okay, so that's one kind of question they might ask you to do. You draw one graph, and then you kind of draw the graph of the right hand side or the other side on top of it, and you see where they intersect one another, and you get a rough answer for what the actual solution to the equation is. And again, there's a margin of tolerance, so you're allowed to be like 1 or 2 decimal places off the actual answer, but that's kind of like how you solve it. In the next video, we'll look at how to solve the hardest kind of versions of these questions.